getting those 2 ATPs. We also are breaking down that creatine phosphate into creatine. That's only getting us 1 ATP. So we're getting about 3 ATPs, not very much. That pyruvic acid now that we're producing from breaking down the glucose, now we don't have any oxygen to convert more ATP. So that basically gets broken into a free radical called lactic acid. Lactic acid gets secreted out into the blood as our waste products. And we all know if we have high lactic acid, that causes our pain and soreness afterwards. Our body breaks down. So that's why after a hard workout, we're sore, and that's that lactic acid buildup. So again, it's a waste product our body has to take care of. So you can see a big difference. Without oxygen, we can produce 3 ATP. With oxygen, we can not only produce our 3 ATP, but we can get another 34 ATP out of that. And that's how our body basically breaks down over time. So that's going to go the main concept that I want to talk about in there. We'll talk more about this later in other aspects, but that's the big thing I want to know, and you're not going to be held responsible for the Krebs cycle. So muscle performance now. So muscle performance, basically, this is our ability to use the force, our maximum amount of tension, and the endurance is how long can we perform that. And this is what we build up. We build up through lifting and building more muscle, basically tearing and building more muscle builds up our force. And then by building up our lung capacity and our endurance, that gives us how much longer we can continue to provide oxygen to the area so we can keep building up our muscles. And that's really the area to do. Now, we do this by a couple different ways. One, again, muscle fibers, the building and that, we do this with supplements and lifting and building. And two, we do it through physical conditioning to build up our lungs. Now, there are two types of muscles we have out there. We have our fast and our slow, or our fast twitch and our slow twitch muscles. Our fast twitch muscles are those going to be quick lifting. This is when we bodybuilding and us. We're building our fast twitch. Our slow twitch muscles last for a long period of time. These are in our legs when we're doing our running and lasting for long periods of time. Our exploding muscles and our long lasting muscles. And we have to have a combination of both to accomplish our tasks. So majority of our muscles are going to be large in diameter, tons of myofibrils, and we're continually building those up. The larger we build our muscles, the larger glycogen reserves we can store. But we don't have a ton of mitochondria in these areas. So again, we're really basing on these. And these are, again, our big red muscles that gives us those high energy, high quick stores on there. So that's kind of on here where our slow fibers are going to be smaller. They're going to take longer to contract, so we take a warm-up period, but they can continue to contract and use for longer periods of time. Vice versa, their oxygen supply, they're going to have more oxygen because there's going to be more capillaries to them. And because we can get more oxygen to them, they're going to have higher abilities to have mitochondria and be able to basically, excuse me, keep that ability to keep creating ATP through those stores. So that's going to be the big difference between the two. We keep doing that through physical conditioning is where it's going to basically building up our muscles, and we build up both. We're going to build up our anaerobic ability, and how we build that up is by building more muscle. The more muscle fibers we can build, getting our muscles bigger, our explosive muscles, the more glycogen stores we can carry. Again, shorter use, but explosive use. Anaerobic endurance, again, we're building more oxygen supply, and we're building those as well. But we're getting our body's ability to provide oxygen for a longer period of time and use that. Lastly, in muscles, we do have 3 muscle types. Again, we've been focusing on skeletal, which is a big one, but cardiac is going to be a huge function we will talk about, and then our smooth muscle as well. So this is our last area where we're going to finish off on these two. And our cardiac muscle, again, is also a nucleated muscle. The cells are pretty small, but they're very specialized. And the cardiac muscle, obviously, is only found in the heart. So our cardiac muscle tissue, when we look at it, it looks like skeletal. You can see we have nucleated areas in here where our skeletal has multinucleated. These are nucleated because the body has to, the cardiac muscles have to be able to talk to each other. But they have a specific way that they do and a specific way that they contract. Some of the biggest differences, though, is the cardiac muscles are branched and they are specific ways to they talk and how they move. and how they respond to that area. So um, the other muscles that we're going to do, and I'll talk about cardiac more in another area, is our smooth muscles. Now, our smooth muscles, we do not really have control over. Now, that being said, if you meditate, if you do, there are some people who can do really good job and control their smooth muscle through their vagus nerve and other contractions, but typically we cannot control the smooth muscles. Those are usually our muscles of digestion, our visceral muscles around our organs. These usually move in a peristalsis type motion. Think about from the mouth to the anus, and basically we have to kind of move that tissue along. It also works around in other areas as well. These usually have one single nucleus to it, and they have a shape. And basically the locations, again, that you found, they find around body parts. They're in sheets, they're bundles, they're sheath, they're around the blood vessels, and they help regulate when our vessels dilate and when they contract. They're also the sphincters and form those rings around from up on our mouth, doing that peristaltic motion down to the anus that I talked about. So that's our main function and how they're controlled. So let's talk a little bit about the anatomy of each of the muscles. And again, skeletal muscles can present in a lot of different ways. They're usually kind of a long format on here, long positional area, and they cover area. They can form in sheets, but they normally have a muscle belly and an insertion and a origin of how the muscle goes. Whereas that smooth muscle is around objects and it's more circular. Usually in there, can perform, like I said, in sheets and other aspects. Most of the muscles is basically has an origin, or where the main muscle starts at. That's where the muscle basically attaches. It doesn't usually, in most cases, not always, there's no such thing as 100% in medicine, but in most cases that origin is where that muscle sits. And the insertion is where it attaches to and moves that. So a muscle usually shortens in one direction. So again, if I'm contracting my bicep, I'm bringing my arm, my forearm, up. And that area where I'm contracting. Then when I want to bring my arm up on my shoulder, I'm bringing my arm up on my shoulder. I'm not moving my shoulder down, or I'm not moving my arm down. So there's an origin, which is the main location of the muscle, and the insertion is what it acts on, and then that gives us the action that we have. And then the origin, again, remains stationary, and the insertion site moves, it contracts, and it moves whatever we're trying to move on. A lot of muscles are named, and I'm going to get into that based on their origin insertion as well. Not all muscles are. The gastrocnemius is in the calf. So this is, origin is basically on the distal femur. The gastroc has two heads, one on the medial and one on the lateral aspect of the distal femur. It inserts on the calcaneus through binding with the soleus muscle into the Achilles tendon. When that pulls on the calcaneus, the back half of the calcaneus pulls up, the fore half goes down, and that's where we get that plantar flexion, or we get a bending forward of the foot. So that's an example of moving. But again, the gastroc is its own specific name, same as the soleus it is. And that's how we move. But we do have naming of some skeletal muscles. And the methods which we named them is basically the orientation of the muscle fibers, the structural features, shape, length, size, or relationship. So there's different ways that we do that. A lot of muscles, though, the first part of the name refers to the origin. The second part refers to the insertion area. So the sternohyoid. Well, basically the origin is the sternum, and it inserts on the hyoid bone. Basically, the hyoid bone is that floating bone up in the jaw below the tongue. So that's muscle. The sternocleidomastoidus basically is the sternum. What do you think else? The clavicle and the mastoid process of the bone. And this allows turning function and bending around the neck, because the mastoid process is up on the skull near the mandible. So different ways we can name them. Usually they can refer to what the function is. Example, extensor carpi radialis muscles. Well, this is an extensor muscle of the carpi radialis, which is on the hand on the radial side. So different names based on there, you can kind of figure out where they are as well. Big thing I want you to know is the typical naming is based on origin and insertion. is the usual way that we will do that. I'm not going to go over skeletal, axial, muscles of the face, those different things like that, because they do different type of actions on there. I think kind of what I told you is the big thing that I'm looking for here. So let's kind of go over here. Here is the sternum. This is actually called the mandible portion of the manubrium, excuse me, portion of that. So the sternohyoid muscle inserts on the sternum, originates on the sternum and attaches to the hyoid. Let's see if we can see the sternocleidomastoid, which is right here. So it inserts basically on the sternum and the clavicle and goes up to the mandible. So the stylohyoid comes from the stylus process off the mandible down on the hyoid. So these are, again, our naming type of things. It doesn't work true with every single muscle, but it works with a lot of different muscles, and that's basically our main shape of things and how it goes. So that's kind of where I really wanted to focus on here. We have other forms of the muscle, again, that form other aspects, muscles of the pelvic floor, areas. And again, I'm not getting to huge because this is a review of the muscles themselves. A couple other things that we look at, and I do want you to know some basic names of muscles you should know. The trapezius, for instance, big area, big muscles. The triceps, the biceps. As we come around the front of the chest here and kind of look at back, the pectoralis major, the pectoralis minor. Should know certain names of most muscle groups. Not so much worried about the supraspinatus, infraspinatus, the minor ones. Not worried about looking that you know major muscle groups. If we point to an area and go, what are the major muscle groups of this extremity, this body part and such? Those are going to be areas, or if I say from what's the major muscles and what's the action that the biceps performs. Those are kind of simple things. You should be able to think those through in your head. And be able to talk about, if I go to the arm, well, we've got a biceps, we've got our triceps. Not, again, so much worried about the muscles down here on the arms. So we can kind of skip into that area. Same with the leg. Again, probably want you to know a little bit the muscles here, the vastus lateralis, vastus medialis, and the rectus femoris. These are all going to be main areas of the quadriceps. Not so much worried with the back, except just calling them the hamstring as a unit. The gluteus maximus, gluteus minimus. When we're dealing with the calf, again, the gastrocnemius is the most outside, and it actually crosses the knee joint, where the soleus actually inserts on the tibia and is on the inside. So the gastroc on the outside, the soleus on the inside, they both come down and their tendons can join into the Achilles tendon, which inserts on the calcaneus. So those are all, again, things that I do want you to know and want you to be familiar with, and then the motions that you're going to get from that as well. Lastly, talking aging in the muscular system. Again, we've got to be continually moving our muscles, building them, and the more that we're using them and build them up, the bigger they get. They have those reserves. They can store more energy. If we don't use them, they can become smaller. They can atrophy. We can reduce our strength. And as with time, we reduce our ability as we stop walking. We stop going through. They can't move blood vessels as well. We don't get that pumping sensation through. So a lot of different things in aging can decrease the entire body. And we'll talk that more when we get more into geriatrics. Our muscles do work with all our other systems. Basically, with our cardiovascular, we're building up our energy to build up our heart muscles. We're building up our diaphragm and our muscles, our accessory muscles around with our respiratory system. Our smooth muscles do correct. We aren't really building those up, but those interact around with our nervous system. So a whole bunch of functions that the skeletal muscles do, smooth muscles do, and cardiac muscles do. So that's a quick review, and hopefully this worked out.